Hello friends, I am Akshay from TeKnowledGeek and welcome to the tutorial. We will talk about some questions you may face in Big Data interview, and let's begin. Please watch till the end. So first question is obvious. What is big data? So big data is a data set that is too large or complex to be dealt with any traditional data processing application software. So too large means that is the beyond the capacity of a single server to process it and manage it or store it. And complex means it has not only the structured data, it has like unstructured or semi-structured data. So that is complex kind of data to process. And third is like there is ambiguity in the data quality, and fourth is like how frequent the data is coming. So if the data is coming in real time, that is also the beyond the capacity of any traditional data processing system, which are not too capable of real time processing of data. So if you get these kind of characteristics of in any data, then you can call it like a big data. This term big data is popularized by John Massey and is in use till 90s. So big data include the data set which sizes beyond the ability of commonly used software tools like Oracle RDBMS, like Teradata RDBMS, which are capable of handling in gigabytes of data or in terabytes of data. But nowadays we dealt with petabyte size of data every day that is coming real time. So you may think of the YouTube where you uploading video lots of hours. I think more than 100 hours of video uploaded in every second. You can think of Facebook where are you all or we all uploading multiple so huge amount of photos and comments, and then we can think of Twitter where we message something. We can think of Instagram where we upload the photo videos. So these all system actually generate petabytes of the data real time, and that is too complex to manage with any traditional or legacy data processing software tools. And second thing is that if the data is too large or too complex, you will be able to process it but not in a desired time span. So you can think of like you run a query in Oracle database and that query giving you result after 16 hours. So that is very much not expected in a like share market or in a uh, business decision making kind of um, solutions, which you expect right much less processing time than that. So big data philosophy encompasses unstructured, semi-structured and the structured data. However, the main focus is on the unstructured data because that is actually holding the lion's share of the data we use every day. So now the next question where we actually described in more like defined way what are the characteristics of big data. So big data can be described by following characteristics. These are called 4V. So first V of the 4 V's is volume. So we already discussed like previously in 80s and 90s or like 10 years ago we dealt with the data which is at most gigabyte of size, and we started with like byte size, then we come to megabyte, then we now in the gigabyte. Nowadays, we are talking of any system using terabyte or petabyte of size, and that is also uploading every day, every hour, or every seconds, I think, in large system like YouTube or Facebook or Instagram, you can think of. So the data volume is a characteristic of the big data. Second characteristic is variety. So there you can think of like how the data you received previously. So that is almost the rectangular data. So data comes in rows and columns, and then you comprise multiple tables in a database, and you can process it using any legacy system or legacy software tools. Nowadays, the data is in photo, is in text, is in social media, tweets, and SMS, and comments, and likes, and then you upload video. So these are the main uh, data we receive in any application tool, and that is called unstructured data. So that is also a characteristic of the big data, the data variety. So you can think of web pages that is having data as XML or JSON. So that is semi-structured data previously, and nowadays also we use structured data in the form of tables and databases. And the most part of the data comprises of the unstructured data, which is uh, sum of the photos, the audios, the social text, which is unstructured, mostly videos. So that is the data variety. That is also a characteristic of big data. And next is data velocity. So we started processing the data in a batch, like if any batch of data coming in a day or in some frequency in a day, so we will process that and get our uh, reports loaded or refreshed. Nowadays data is coming in real time, so you can think of like share market, where millions of bytes are generated every seconds based on the shares uh, up and down and frequency and some knowledge gathering from there. And you can think of any modern physics lab like CERN, where you are getting data in real time in very high volume. So that is also a characteristic of the big data. So big data can come in real time or near real time or in periodic basis or in the batch of data. So data velocity. So last is the veracity. So like this is called the quality of the data. So in this era, whatever data you receive through internet or somewhere else, so we need to think of like a AAA slogan. Anybody can tell anything about any topic. So that is actually giving us the biased data. So data can conflict, can have conflict, can give you the ambiguous outcome, and can hamper your solution or outcome in such a so many ways. So the data quality is also a characteristic of the big data. So data quality is ambiguous, so that is called veracity. And you can extend this list as the data exhaustiveness is also a characteristic of big data. Fine-grained and uniquely lexical, that is also a quality of big data. Relational data and not relational data, that is also a characteristic of big data. And then extensional data, data scalability, data variability, and data value. So these all are the characteristics, extended characteristic you may say, of big data. But primarily you need to think of 4 V's. Next question you may face is, how can we manage big data? So if you want to manage big data, you need to think of any processing system which is not like the legacy system. So here actually we can think of a parallel processing model, that is actually MapReduce, and we can think of a distributed file system which can comprise the data. So the MapReduce model is giving you the parallel processing model, and the distributed file system will give you the scale out idea of storing the data. So scale up is like vertical scaling of any server or system. So that means you are increasing the resources of any system or server based on the volume of the data. So if you scale up, then you need to have you need to give the high price of the resources. If you use, you can think of like you are using 2 GB RAM in your personal laptop, and now you want to upgrade it to the 6 GB, so you need to pay higher price. So apart from that, in big data processing, you need to think of scale out. That means you are horizontally scaling of your system. That means you can create a cluster of very cheap resources, like you have 2 GB of RAM in each server. You can think of like that, and you are comprising of 10 servers. So actually you are having 20 GB of RAM you are using. So that is called scale out. So big data use that kind of distributed processing model. So to explain the MapReduce concept, we can say that is a parallel processing model. An associated implementation was released to process huge amount of the data. With MapReduce, queries are split and distributed across the parallel nodes and processed in parallel, the map step. So all the data according to the input split, it will go to each map function in several nodes, and that will be processed parallelly, and there you are actually reducing the time of data processing, and then the result are shuffles and sorted in between and then fed to the reduce function. That is actually aggregating all the data and give you the final output. An implementation of this MapReduce model was adopted by Apache and created an open source project named Hadoop. Next question you can think of, like what is MapReduce model in extensive way. So MapReduce is a programming model and associated implementation for processing and gathering big data set with a parallel distributed algorithm on a cluster. So this comprises of three main part. One is map, another is shuffle, third is reduce. So here we are actually explaining it with an example. Like you have 2 years and the temperature reading. So you get three temperature reading for 1970s, like 0, 22 and minus 11 degrees centigrade, and two reading for year 1969. So you have 42 and 8. So that is your input. So what map function do? Map function is actually creating a key value pair out of that, and it will write to output to a temporary storage. So it will take the year as a key and create a key value pair between year and temperature. So same happened for 1970s. There will be three key value pair generated. For 1969 there will be two key value pair generated. Then these two data will be sorted based on the key, and then it will give some interim output to reduce the uh, data set going to the reduce function. So in 1970 you get the highest temperature. If you want to get the highest temperature, it will be 22 degrees centigrade, and for 1969 it will be 42. So then that final output will come from the reduce process. So it will process the output based on the key in parallel and give you the final output. So this is in short a description of the MapReduce model. Next question you may face, like, can you write MapReduce in a pseudocode? So you know now, like, the main objective of map function is to create all key value pair from input data. Like, if you create a function map, it will take the document name as an argument and the document content as an argument, and then each word in the document, it will emit the key value pair, like word as a key, and there is a value generated uh, by the function, and it will return this key value pair as a final output. The reduce function is like to aggregate the result from all key value pair from the map function. So it will have, if you think of any function like reduce, so that will have input parameter as word and then partial count, because reduce is not getting the input from map directly, it can get output from the shuffle part. So it will have the partial counts. So each key will be like sorted and aggregated on the local worker node. So that is called like shuffling and sorting. And then these local counts are then aggregated in the reduce function, and it will sum up to the actual value, and then it will emit the total word count per word. So that is a key value pair you are returning from the reduce function. So this is in a way you can write a word count example in a pseudocode using MapReduce algorithm. The next question you may face, like, can you explain shuffle? The shuffle is a part between map and reduce, and it is like, if you are thinking of the word count example, so you get the data like a chain of words, and then you are splitting the data based on your size of the block uh, in your data node, and then each split will be processed by each worker node. So first worker node get, you may think like SQL, DW and SQL again. So it will create 3 key value pair out of these 3 words, and then it will combine locally, like SQL is having 2 occurrences, so then it will sum up to 2, like there is 1 key value pair SQL comma 2, that is the key value pair it's generating. Same happened for the DW, it has only 1 occurrence, so it will create DW comma 1. And then in the shuffle and sort phase, it will actually redistribute, like data from all mapper are now grouped by the key and split among the reducer. So if you have like 6 reduce tasks, there will be 6 split happen between your like yield of the map and combine function, and then these 6 will be sorted in their, you can say in this case in this alphabetic order. So BI will have the 1, and then DW will have like 2 key value pairs, and then SQL have 4 key value pairs, same as for SSAS, SSIS and SSRS. And then these data will be fed to the reduce function, and then reduce function will aggregate the data per key, and then it will produce the final result. So the shuffle is the process by which the system performs the sort and transfer the map output to the reducer output as input. The next question you may face, like, what is input split? We are talking about input split a lot, and how it can happen we'll explain. So you say, like, you have a high volume or large file. So what is called a large file? That means the size greater than the block size of your distributed file system. You can think of HDFS also. So uh, if the block size of the HDFS is 64 megabytes, so I have given it wrong, it's not 64 bytes, it's 64 megabytes. So then the input split will be defined by the block size, and you can, like, mention what could be your min size for the input split and max size for the input split. But usually the block size is between the min size and the max size, and the formula to uh, get the split size is minimum of max size and block size, and then uh, get that value and take the maximum of that size and mean size. So most of the cases, block size is in between mean size and max size, so block size will determine the split size. And next thing to remember, that splits and records are logical. The split does not contain the input data. It is just a reference to the data. Next question you may face, like, can you explain combiner function? So many MapReduce jobs are limited by the bandwidth available on the cluster. So if you give entire key value pair from map to reduce task, it will exhaust the bandwidth available on the cluster. So this function will actually ensure to minimize the data transfer between the map function and the reduce function. So you can think of the example we already discussed, like for year you are getting the temperature reading. So you are generating 3 key value pair in each map function, and then you are actually aggregating it locally. Like, you have 3 key value pair in the map1 function, and using the combiner function you actually take the max out of it, and then pass the maximum data, like in this case 1950 and 20, to the reducer function. The same happened for the other map function. It will be like aggregated locally, so, and then you'll get only 1 key value pair going to the reducer function. So instead of 6 key value pairs, we are only passing 2 key value pairs to the reducer function, and that will actually minimize the data transfer to between map and reduce task, and then final output will be generated by the reduce task. Next question you can think of, like, explain the execution of the distributed MapReduce job. So if you talk about a distributed processing, so that will comprise of 2 types of node, like job tracker node and the task tracker node. And there will be one distributed file system which will have the multiple data node. So if you are triggering one MapReduce program from your client node, so that will actually run a job, and that will get a new job ID and submit the job to the job tracker. And then job tracker node will actually uh, initialize the job, and it will retrieve the input split from your data nodes. And then the job tracker node know what all task tracker node is alive, and by getting the heartbeat, and it will submit the actual MapReduce job to the task tracker node. The task tracker node will run a task tracker function. You can think of, if you're running the MapReduce job in Java, so you can think of any JVM or uh, the other system you can think of as well. So in this JVM, there will be a task tracker, and that will actually run the map task and reduce task, and to do it, it will retrieve the job resources from the data node, and then it will give the final output back to the job tracker node, and that will pass to the client node. So in this way, a distributed parallel processing can happen using a MapReduce job. And the data nodes will have the data and in the reduced redundant way. So if any data node fail, your data will not be lost. It has the replica of the data in multiple data nodes, at least in 3 data nodes, you can say. Thank you so much for watching this video. Please subscribe this channel for more videos. Thank you so much